Every complex ecosystem relies on strict inputs. When flawed data enters an organized system, the result is immediate friction. Operations leaders usually treat claim denials as isolated events, a billing error here, a localized coding mistake there. The data shows a different reality. These denials are systemic, mathematically guaranteed workflow failures that trigger long before the claim is actually submitted. The precise mechanism driving these failures is operational latency. Legacy practice management tools and static clearinghouses operate entirely reactively within this environment. They only surface the outcome of latency weeks after the revenue loss has irreversibly occurred. ClaimCalcPro operates as a counter architecture, built specifically to intercept this upstream friction. The system functions as a layer of proactive operational infrastructure, replacing the static data warehousing typical of legacy repositories. We are going to deconstruct a systemic causes of revenue leakage across complex ecosystems and analyze the exact mechanics of workflow intelligence. Reframing a denial from a localized mistake to a systemic operational event changes how enterprise organizations must evaluate, procure, and deploy software. This diagram represents a typical claim lifecycle. The unseen structural force acting upon it is the delay engine, a mechanism that actively destroys revenue velocity. Multi-system fragmentation creates invisible gaps in the data gathering process, introducing latency directly into the timeline. These gaps represent specific upstream failure points, missing attachments, and incorrect operational sequencing that physically halt progress. Add delayed submission windows and authorization mismatches, and the claim hits hard deadlines and fragments entirely. Coordination of benefits errors then compound these exact delays across multiple, disjointed payer systems. Payer acceptance algorithms are strictly timing-based, entirely rigid, and unforgiving of these gaps. When the payer's algorithm evaluates this fragmented, delayed data packet, it does not look for intent. It mathematically rejects the claim based purely on those upstream timing mismatches. The denial is finalized invisibly, often weeks before the submission failure is officially recorded by the billing department. Solving revenue leakage requires intervening at the precise moment of operational latency, long before the final denial materializes. To fix the mechanics of the delay engine, we have to examine the architectural level, where legacy software falls short. This flowchart illustrates traditional claims software architecture. The top half shows a strictly linear path, operating as a terminal endpoint, designed only to warehouse data. These systems function as static connectors, or passive extensions. Data piles up without a feedback loop to correct it. The bottom half demonstrates ClaimCalcPro's architectural philosophy of workflow orchestration. It utilizes a circular, continuously moving loop that bypasses the funnel entirely. This loop performs immediate denial prevention and intelligent evidence packaging, injecting missing components upstream. The system dynamically generates audit-ready documentation in real time, matching specific payer logic on the fly. Traditional systems isolate administrative actions into disjointed human tasks. ClaimCalcPro converts those operational workflows into reusable, automated enterprise infrastructure. It removes the human-dependent review bottleneck, replacing it with scalable operational intelligence. Implementing a proactive orchestration loop accelerates the reimbursement cycle, transforming administrative friction into revenue velocity. This circular infographic outlines the 5-stage denial lifecycle optimization framework, the core engine driving the platform's efficiency. Stage 1 is delay detection. The platform identifies workflow latency before submission failure occurs. Stage 2 is documentation correlation. Disparate pieces of supporting evidence automatically match directly to the specific requirements of the payer's logic. Stage 3 surfaces predictive denial signals. The system analyzes historical workflow patterns and flags trajectories associated with failure. Stage 4 activates escalation intelligence. High-risk data packets are automatically pulled from the main track. Finally, Stage 5 applies recovery workflow automation, closing the loop and rapidly outputting completed supplemental packets. This predictive capability allows the platform to intervene well before the payer's algorithm runs its course. Routing these high-risk claims directly into priority queues ensures specialized review exactly where it is needed most. This drastically reduces the manual labor traditionally required during appeals and supplemental submissions. These 5 stages collectively work to eliminate the severe human dependency bottlenecks that financially cripple traditional claims ecosystems today. This map represents the macrostructure of the enterprise software market. To understand the value here, we have to look past the individual claim and examine how these industrial data hubs operate. Most software competitors specialize narrowly in just one isolated vertical, such as healthcare or dental, leaving massive gaps between industries. ClaimCalcPro gains a strategic investor-grade advantage by consolidating fragmented non-property verticals like workers' comp, motor vehicle accidents, Medicaid, and VA claims. This diagram shows multiple distinct vertical clusters connecting to form cross-domain intelligence. This is the primary defensible moat created by a multi-vertical approach. Analyzing workflow latency across varying industries creates network effects that siloed competitors simply cannot replicate. The architecture serves as a layer of compliance-aware enterprise infrastructure, operating across complex workflows that niche administrative tools cannot touch. For investors, this structure delivers 2 core value drivers: recurring operational dependency and deep compliance-driven stickiness. Consolidating specialized high-volume verticals like Medicare, the VA, and workers' comp allows the platform to capture the aggregate administrative spending of these multi-billion-dollar markets. The platform architects the operational systems that generate claim results, rather than just logging the outcomes of those systems. Diagnosing operational causality secures a unique market position that commands the high recurring dependency found in critical enterprise infrastructure.